welcome to another video of mine. In this video we're going to be talking about maybe we're going to be learning about different parts of the James Webb Space Telescope. Wherever you search James Webb, there's a lot of data that comes. But the site that I took the data was JWST.nasa.gov. I think that's the best website to learn about James Webb and its discoveries, how it was launched and how it's gonna be working and when it's gonna start taking pictures, studying the universe. You can find a lot of data in there. I had put the site down below in the description, so make sure you visit it. And yeah, that's it. So let's begin. 3, 2, 1. Listen guys, if you ever want to make James Webb a model of it, I had put a link in the description below. It's a PDF that you can download from the site of NASA, JWST, that place I said earlier, and you can find out a lot of data about James Webb in that PDF, like the names of different parts. Maybe it's not all the parts, but necessary and very important parts of the James Webb Space Telescope are in that document. And I also took those names, searched them in the internet, gathered all the data I could, and now I'm ready to present them to you. Number 1 is the spacecraft bus. If you open the PDF, the first thing you will come across is the spacecraft bus. And what is exactly the spacecraft bus? It provides the necessary support functions for the operation of the James Webb Observatory. And this part contains of many subsystems, some major subsystems, which I'm going to tell you right now. There are 6 of them. Yeah, 6 of them. Let's begin those 6 ones and then continue the rest of the video. Number 1 is the electrical power subsystem. What does it do? It actually if you haven't watched my last video, the video I uploaded before this video, well, if you ever watched that, you'll see that it talked about the sun shields of James Webb, that James Webb has to stand like this to so it won't get overheated. The sunlight hits the sun shields and gets, they get reflected, the light of the sun gets reflected, and in that way it keeps the spacecraft cool. Actually, some of those photons that are hitting the sun shield go inside this electrical power subsystem, and it turns those into fuel or energy to keep the spacecraft or maybe I should say observatory full of fuel so it can work better. So it's actually a charger for the spacecraft. Number 2 is the added control subsystem. What does it do exactly? Is that, let me tell you. From its name, it's obvious. It controls the attitude and how much is tilted the spacecraft is. It controls those stuff. But its main job is to take commands from the science instrument payload on the observatory and turn it into the position we want, that science instrument payload wants. So we can see the object we want. Like we want an exoplanet to see, we want to see an exoplanet. So what are we gonna do here is that we're gonna command the science instrument payload, and that will command to the attitude control subsystem, and that will turn the spacecraft or the observatory the way we want. Next is communication subsystem. What does it do is actually take commands from the Earth's mission control, from the Earth, and the commands we give to different subsystems and all the stuff aboard the spacecraft or observatory. And its job is communication with Earth. Next is command and data handling subsystem. which just obvious from its name. It handles data and command, and the spacecraft is whole based on that somehow. You know, it's command and data. I don't know. Next, we have the propulsion subsystem. What does the propulsion subsystem do? Is that it actually controls the temperature of the spacecraft or observatory. Which one do I want to say? Observatory or spacecraft? Comment below so which one I should say. Or I will continue saying observatory, spacecraft, observatory, or. All the stuff till the end of my life. Or I should say till the end of the life of this YouTube channel. So since I hope you're enjoying till now, so make sure to subscribe and like the video. And if you didn't like it, I won't be sad if you click the dislike button. And also tell me in the comments below why didn't you like it so I can improve this video even more. And I know I have some grammatical errors, but it's not on my own. Okay, but we're talking about the propulsion system, and what does it do? It actually its job is to control, propulsion. What does that mean? It has a fuel tank support on the propulsion subsystem, and those fuel tanks, and plus that with some engines, and it actually takes commands from the main command module on this observatory, which I have no idea which part is it, because all parts are principal. If any of them aren't there, the spacecraft won't be there, or the observatory won't be there. Come on guys, comment down below, okay, so I can find out what to say, observatory or spacecraft. Okay, maybe I don't want to pop out your mind, so I'm gonna continue saying observatory. Alright, next we have this thermal control subsystem. The propulsion system's main job was to take the spacecraft ahead or turn it around the way the attitude subsystem says. But the thermal control subsystem, its main job is to actually control the temperature aboard the spacecraft. Observatory. Okay, so it won't get overheated, so its science instruments won't go bang. Alright, now let's continue to the mirrors. Okay, let's continue with the mirrors. What are the mirrors of this James Webb Space Telescope? I'm gonna explain them a little bit more. So, the mirror's main job is actually taking pictures. The light of the cosmos enters into the primary mirror. The primary mirror is made of 18 hexagonal mirror segments, which are made of beryllium and are gold-plated, meaning they are covered with layers of gold, which help us see better. The mirror segment is actually hexagonal, and because they had to fold it up to fit it inside the Ariane 5 rocket, which I mentioned in the last video. And also, the secondary mirror, its main job, so let me just tell you, there are lots of mirrors on the observatory, but let's just talk about the primary and the secondary mirror, which are the most important. I hadn't talked about the secondary mirror in the last video, so you can enjoy. And the secondary mirror is actually also gold-plated, and I think it's also made of beryllium, because I don't have much data about that. And here's a picture of it. So it's connected to the primary mirror with 3 handles, which can be folded up. And actually, when the light enters the primary mirror reflects those lights into the secondary mirror. There are cameras installed inside the secondary mirror, which then we can picture, I guess. And so the light gets reflected many times until we can take it on the camera. So I don't have time to explain all those mirrors that are aboard this observatory. Okay, so these were all the parts I want to talk about. There are some other science instrument payloads aboard the spacecraft, which actually take data. There's also an infrared camera. Why? I'm going to explain why there's an infrared camera on the spacecraft. Oh my god, I need to say observatory. Please remind me of this. Well, of course, this is not a live video, so there's no way you can remind me. But make sure to say in the comments, I'm not still done with it. Why there's an infrared camera aboard the spacecraft? Observatory. Well, the infrared camera is there because the light of the stars that formed like just 1 billion years after the Big Bang have turned into infrared light. Why is that? Well, the universe is expanding. And we know when something is moving away from us, the more faster it goes, the more it gets redshifted, meaning that its color will get red. Those first stars and galaxies, lights were ultraviolet and some of them were visible. But since they're, going away from us, they're getting further away from us, so that's why we need infrared. They're getting redshifted, so we need to, their wavelength is getting bigger, so we need to have an infrared camera, which the Hubble Space Telescope didn't have it. I guess it had a newer infrared camera, but the James Webb has an infrared camera. It also has so many other cameras, but I want to talk about the infrared camera in this video. So the infrared camera's main job is to actually point to those stars that their light is redshifted, and so we can take pictures of them, making them visible to us. If you ever have seen the HUDF picture or Hubble Ultra Deep Field image, you'll see that there are so many galaxies. This video took so many days to make, okay? Maybe even months, or even not yours, okay, not yours. So the Hubble Space Telescope orbits the Earth every 19 minutes. The James Webb is going to be orbiting the Sun, and I guess it will be orbiting it every 365 days, okay? Maybe more, because it's 1.5 million further from the Sun than the Earth is. And yeah, that's why its orbit's a little bit slower than yours. Or maybe it's orbiting the same speed as the Earth, I don't know, but I assume that it's going to be orbiting the Sun with the speed of 365 in 365 days. It's going to be orbiting the Sun once, so it's going to have the same year as us. Okay, so it can have a Merry Christmas. Remember that on 21st of December is the anniversary of the launch of the James Webb Space Telescope. So mark up that in your calendar so you'll remember to celebrate it on the day of Christmas. And yeah, that's all I want to talk about in this video. Okay, the HUDF picture is actually super cool. It's the size of a little teeny tiny coin in the sky. The Hubble Space Telescope had to picture that spot many times to see those galaxies. And when we pointed the telescope towards there, we saw, oh my god, how many galaxies we were missing. They were so small, they could hardly appear in the Hubble Space Telescope. Every new telescope we launch, we don't know what's going to be after it. This is what the thing I'm going to explain in the next video. We don't know what are we going to see with the James Webb Space Telescope. So make sure to subscribe and like and turn on the notification bell so you won't miss the next video. It's going to be super cool. Bye!